Hi everyone, welcome to the channel. In this video, we are going to see how to build a random forest classifier for the IRIS dataset. So we start with importing the necessary libraries. So the random forest classifier is present in the ensemble module of scikit-learn. So we import the random forest classifier from the ensemble module. We also need to split our data into training data and test data. So we import the train test split function from the model selection module. We are also going to evaluate our model. So for that, we import the confusion matrix and the accuracy score from the metrics module of scikit-learn. Now this sklearn denotes the scikit-learn library of Python. Here we use it to load the IRIS dataset. We commonly use this IRIS dataset to practice the machine learning algorithms. This dataset contains multiple samples of IRIS flowers, with each sample belonging to one of the three species, namely Setosa, versicolor, and virginica. So in the IRIS dataset, we have three species of flower samples, namely Setosa, versicolor, and virginica. Each IRIS flower sample has four features, namely sepal length, sepal width, petal length, and petal width. So here, our sklearn.datasets is a module for sklearn, which contains various data sets for practicing the machine learning algorithms. So from the sklearn.datasets, we are importing the load IRIS function. So here, first, using the load IRIS function, we load the IRIS dataset into a variable called IRIS. So here, the data is loaded into X variable and the target is loaded into the Y variable. X variable is a 2D array where each row represents a sample and each column represents a feature of the flower, namely sepal length, sepal width, petal length, and petal width. So similarly, Y variable is a 1D array which contains the target labels, namely our species labels for each of the sample in the X variable. So these target labels are integers, where 0 means Setosa, 1 means versicolor, and 2 represents virginica. I try to print the X value. When I try to run this code, you can see that X variable is a 2D array where each row represents a sample of the flower and each of the column represents the sepal length, sepal width, petal length, and petal width. Similarly, I also try to print the Y value. So here you can see that Y value is a one-dimensional array and it contains the target labels. Our target label is the species label of the flower, the species of the flower. These target labels are integers and 0 means Setosa, 1 means versicolor, and 2 represents virginica. So that is about our IRIS data set. And here the random forest classifier algorithm constructs decision trees on the data samples of the data set. And it gets the prediction from each of the decision trees. And finally, it selects the best solution through voting. So here, next we split the data into training data set and test data set. So here, considering the first line, 20% of the data from the IRIS dataset will be used for testing and remaining for training. So here we use the train test split function and we split the dataset. The input arrays are given here, X variable and the Y variable, and then the test size and then the random state value. So here our test size is 0.2, which indicates that 20% of the data from the IRIS dataset will be used for testing and the remaining will be used for training. We can also use to the random forest classifier, we also use the N estimators parameter, which controls the number of decision trees in the random forest. So higher the number of decision trees, it improves the performance of the random forest. And we also have the random state parameter in the train test split function. It sets the random seed. It ensures that randomization in the algorithm is consistent across multiple runs. So when we use the same random state value, it will produce the same results each time you run the code. So we initialize the random forest classifier by using the N estimators and the random state value. And after initializing the random forest classifier, we have to train the classifier. So we can train the classifier by using the fit method here. So we use it. So we fit the random forest class. We use the fit method and train the random forest classifier. And we pass the training data set as input to the fit method. And then we use the result for making predictions on the test data features. So here x underscore test will contain the features of the test data set, and y underscore test will contain the actual species labels. So y underscore pred will contain the predicted species labels. So here the predictions made by the random forest classifier on the test feature labels on the test data set is taken, and those predictions are stored in a variable called as y underscore pred. So next we evaluate the model. So for evaluating the model's performance, we use metrics, namely confusion matrix and classification report. So confusion matrix is obtained by using the confusion underscore matrix function, and classification report is obtained by using the classification underscore report function. And in the confusion matrix, each row represents the actual class and each column represents the predicted class. So the first row represents class 0, namely Setosa. Second row represents class 1, namely versicolor, and third row represents class 2, namely Virginica. The diagonal elements in your confusion matrix represents the number of correctly predicted instances for each class. So now, for example, when I run this code, this is the output which I get. So here the diagonal elements in this is the confusion matrix. The diagonal elements in this confusion matrix represents the number of correctly predicted instances. Row 0 represents Setosa. So class 0 is Setosa. So from the confusion matrix, 10 instances were correctly predicted as Setosa, 9 instances were correctly predicted as versicolor, and 11 instances were correctly predicted as Virginica. The non-diagonal elements of the confusion matrix indicate the misclassified instances. So here, if you see the non-diagonal elements are all 0, it means that there are no misclassifications. Next, moving on to the classification report. Classification report is a text report showing the precision, recall, F1 score, and the accuracy values. The formula for calculating these values is precision is nothing but the total number of true positives divided by true positives plus false positives in our result. And the recall is calculated as the total number of true positives divided by the true positives plus false negatives in our result. So similarly, the F1 score is calculated as the harmonic mean of precision and recall. So the formula is 2 into precision into recall divided by the sum of precision and recall. So similarly, the accuracy score is nothing but, so here in our result, the accuracy score is 1, which means indicating that all predictions across all the classes are correct. So here, to summarize, you can see that the random forest classifier performed well on the IRIS dataset and achieved perfect accuracy, precision, recall, and F1 score for each individual class in the dataset. So class 0 is Setosa, class 1 is versicolor, and class 2 is Virginica. And our random forest classifier has performed well on the IRIS on our IRIS test dataset and for each of the individual class in the dataset. So that's all with the random forest classifier for the IRIS dataset. See you in my next video. Take care. Bye-bye.
Don't forget to subscribe and press the bell icon and press all to get instant updates.